Was the Big Bang really the literal beginning of everything? Or could it be that something else existed before the birth of the cosmos? Well, the British Nobel Prize winner in physics, Roger Penrose, knows exactly how he answers this question. He is convinced that our universe emerged directly from a precursor universe. And this is by no means an exceptional cosmic event, but an eternal fixed pattern that repeats itself over and over again. And indeed, a sensational discovery by the James Webb Telescope now also suggests that our world is by no means unique. After all, the data indicates that our cosmic world was only created by merging with another universe. At first glance, the matter seems clear. Since, according to our current theories, time also only began with the Big Bang, one might think that the question of what came before that is superfluous from the outset. In this case, the answer would simply be nothing. And a certain Stephen Hawking was also convinced of this notion. He said, the question of what was before the Big Bang is just as pointless as asking which direction is further north than the North Pole. Because time itself only began with the Big Bang, this is an event that cannot have been caused by anything or anyone. The laws of nature themselves tell us that the universe can come into being without the need for energy or a cause. So far, so clear. However, we should not forget that other renowned experts have their problems with precisely this assumption, and that the Big Bang theory alone is by no means capable of solving all cosmic mysteries. And this starts with very fundamental points. After all, what actually led to something suddenly emerging out of nothing 13.8 billion years ago? Was there a trigger, or was it pure coincidence? And how can matter arise out of nothing at all? No less confusing is the question of why matter and radiation are so evenly distributed in the universe. No matter in which direction or at what distance we look, on a large scale, galaxies, gas nebulae, and radiation always show similar densities and distributions. The current explanations point to cosmic inflation, and thus to a phase of growth faster than the speed of light, in which the primordial universe expanded by a factor of 1,030 to 101,000 within fractions of a second. But what if our picture of cosmic development simply does not match reality? What if the history of the universe ultimately turned out quite differently than our established assumptions suggest? After all, the James Webb Telescope has now shown us several times that there are objects out there that push our standard model of cosmology to its limits. First and foremost, of course, are the so-called universe breakers, which are very early galaxies that were as massive as the Milky Way is today, a good 13 billion years ago. However, our standard model says that the normal matter required for this was not actually present so soon after the Big Bang. Furthermore, Webb has also detected very early black holes that also appear to be inexplicably massive, and confirmed once again at another location that the cosmos does not do what it should on paper when it comes to expansion either. More specifically, this refers to the expansion rate of the universe, which significantly exceeds its theoretically predicted value in reality. But what do all these astronomical inconsistencies mean for the big picture? After all, if we are so far off the mark when it comes to structure formation processes and expansion rates, isn't it possible that we have also been mistaken about a much more fundamental point? The universe before the universe? Although the Big Bang theory has enjoyed a prominent position for quite some time, it is by no means uncontroversial. Quite the opposite, in fact, because there are now a whole range of exciting alternatives that approach the question of the cosmic beginning from a slightly different direction. And even if the corresponding theories sometimes differ significantly from one another, they do have one fundamental thing in common. They assume that we have to abandon the idea that the Big Bang was the beginning of everything. Because if another universe really did exist before ours, the much-cited Big Bang was ultimately merely the explosive transition from one cosmos to the next, and would therefore be much more aptly described as a big bounce. Surprisingly, the idea of this cosmic interplay of destruction and rebirth is anything but new. And true to the motto, what expands can also contract again. Cyclic models in cosmology are still quite popular today. And for good reason. After all, this approach is able to circumvent the problem of causality. If matter has always existed in an eternal cycle, the question of how something can arise from absolute nothingness is also a thing of the past, because it never existed in the first place. We rack our brains over the strange uniformity of the cosmos because this could now be explained by cosmic contraction, which distributes practically everything equally. And the cause of the Big Bang would also be quickly found. It would simply be the end of the previous cycle, which is always followed by a new chapter of expansion. Roger Penrose, the British winner of the Nobel Prize in Physics, is also convinced of the cyclical nature of the universe. In principle, the universe should expand forever until all matter has decayed and become light. And this extreme environment, in which nothing has a time or space reference to one another, inevitably leads to the cosmos exploding into its new existence. Sounds pretty exciting, doesn't it? However, it gets even more exciting when we consider that Penrose even claims to have found tangible evidence for his cyclic model. More specifically, he and his colleagues have detected a remarkable signal in the cosmic microwave background, or CMB for short, that is thought to be a direct relic from a precursor universe. These are a series of circular features that were detected in the Planck and WMAP satellite data and correspond to multiples of the average CMB temperature fluctuations. And why the discovery of these so-called Hawking points could be so groundbreaking becomes clear if we consider what, according to Penrose, happens to supermassive black holes at the end of a cosmic era. They would evaporate completely into Hawking radiation, but in doing so, they would take all of the radiated energy into the subsequent universe in the form of a single Hawking point. The photons created in the process scatter in an expanding region, but they are only released when they finally appear in the microwave background radiation of the next cosmos. The corresponding region would then look like a disk to us, with the diameter of our full moon. And guess what the spots that Penrose identified in the CMB sky would look like? Was our universe swallowed by another? As already mentioned, the cyclic model is just one of several alternative approaches competing with the Big Bang. After all, there is also the theory that our cosmos is in fact just a tiny link in an infinite chain of universes. This idea is based on chaotic inflation, which states that most of the cosmos has been expanding in an eternally inflationary manner, with this process only coming to a halt in bubble-shaped subregions where independent universes eventually form. And now for the kicker. A study published in the Journal of Cosmology and Astroparticle Physics actually concludes that our observations in space are best explained by the fact that our cosmic world has merged with another. To understand what this is all about, however, we have to briefly return to the puzzle of the expansion of a universe. Basically, the expansion rate is described by the so-called Hubble constant. And if we determine this theoretically, we get a value of 67 kilometers per second per megaparsec. But as soon as we include supernovae, red giants, gravitational lenses, and Cepheids, in other words, variable stars, the Hubble constant suddenly jumps to 73 kilometers per second per megaparsec. In other words, the universe is expanding much faster today than it should be. But how can that be? After all, on paper, the expansion of space should actually be taking place at the same speed everywhere. Well, one possible explanation would be that the past measurement results were distorted by errors and inaccuracies. And to test this very assumption, the James Webb Telescope recently examined 320 Cepheids and delivered the equally sobering and unequivocal finding that the previously observed discrepancies do indeed correspond to reality. However, a groundbreaking new approach to solving this problem is to assume that our universe is currently merging with other universes. And not just recently either. The real reason for cosmological inflation is said to have been that our young universe was swallowed up by a larger mother universe. Subsequently, our cosmos followed in its motherly footsteps and has since been on the verge of colliding with other baby universes in order to eventually absorb them as well. But how do you come up with such a far-out theory in the first place? Well, by developing a mathematical model that examines the effects that several interacting universes would have on our cosmic world. The researchers' calculations showed that such a process would increase the volume of our universe, and thus create an increase in volume that our measuring instruments interpret as the expansion of space. In the same breath, the experts also examined the expansion rate that would be expected in such a scenario. And surprisingly, the results ultimately agreed with our observations even better than the traditional standard model. But how can such a theory be proven? Is it even possible to directly observe another universe? Well, unfortunately not. And so it happens that scientists are currently looking for other ways to substantiate the merger of worlds with tangible data. More specifically, they are conducting various experiments to study the microwave background, because who knows, maybe it not only contains mysterious Hawking points, but also unknown properties that will possibly open an indirect door to a new world for us. And did you know that the button under our video can open the door to a new world of subscriptions? Click the thumbs up and subscribe now to never miss a new video from us again. We'll see you soon.